Good morning, my students. Our lesson today in calculus is applications on derivative. First, slope of the tangent and normal to a curve. As we talked before in the previous year, slope of the straight line, if you have two given points x1, y1 and x2, y2, the slope is y2 minus y1 over x2 minus x1. And if you have a linear equation, the slope is negative coefficient of x divided coefficient of y. And the slope from a given angle theta, which the straight line makes with the positive direction of x-axis, is tan theta. And in this lesson, the slope of the tangent is the first derivative we talked before in the previous lesson. So if you have function y equal f of x, so the slope of the tangent to this curve at any point xy lying on it is dy by dx. If you look to the opposite graph, this figure, the straight line, which is the tangent to a curve, touch the curve at point x1, y1, and the straight line perpendicular to this curve, or perpendicular to this straight line at the indicated point x1, y1 is called normal to this curve. So the slope of the tangent to this curve at the point x1, y1 lying on it is dy by dx, also equal tan theta, where theta is the positive angle which the straight lines makes with the positive direction of x-axis. Remember that if you have two straight lines are parallel, so their slopes are equal. So if line 1 parallel to line 2, then m1 equal m2. And if the two straight lines are perpendicular, then the product of their slopes equal -1. Now let's take the equations of tangent and normal to a curve. The equation of tangent to the curve is y minus y1 equals mx minus x1. M is the slope of the tangent, x1, y1 is the point which the tangent touch the curve on it. So this point lies on the curve and also lie on the straight line. Equation of normal to the curve at the same point x1, y1 also is y minus y1 equal -1 over m x minus x1. Now let's take some examples. Example number 1. Find the points which lie on the curve y equal x bar 3 minus 4x plus 3, at which the tangent makes with the positive direction, at which the tangent makes a positive angle of measure 135 with the positive direction of x-axis. First of all, y equal x bar 3 minus 4x plus 3. So dy by dx in this case will be 3x squared minus 4. This is the first derivative. This derivative will equal also slope of the tangent, which is mean tan theta. And theta in this case equal 135. So dy by dx equal tan 135, which is mean -1. I mean that 3x squared minus 4 equal -1. By solving this quadratic equation, x will be equal positive or -1. Then I will substitute ix in the equation of the curve, one time by 1 and the other time by -1. When x equal 1, y equal 1 bar 3 minus 4 times 1 plus 3 will be 0. And when x equal -1, y will be equal 6. So the points 1 and 0, -1 and 6 are the points which lie on the curve x bar 3 minus 4x plus 3. Example number 2. Find the slope of the normal to the curve of the function y equal tan pi minus 2 over 3x at a point pi and root 3. I will also get the first derivative. Dy by dx equal -2 over 3, 6 squared pi minus 2 over 3x. By substituting x by the given point pi, you will find that the slope of the tangent to the curve equal -2 over 3, 6 squared pi minus 2 over 3 pi. The angle in this case is in radian measure. To convert it into degree measure, you will multiply it by 180 over pi. You will find that the slope of the tangent will be -8 over 3. The slope of the normal is -1 over m. -1 divided -8 over 3 will be +3 over 8. Example number 3. Find the two equations of tangent and normal to the curve y equal to x bar 3 minus 4x squared plus 3 at the point lying on the curve whose abscissa equals 2. This new word abscissa means when x equal 2. So you have the value of x. Now direct substitution to get the value of y. Y equal 2 times 2 power 3 minus 4 times 2 power 2 plus 3 will be 3. So the point 2 and 3 lies on the curve. Now the first derivative dy by dx. dy by dx equals 6x squared minus 8x. By substituting by the indicated point 2 and 3, you will find that the slope of the tangent to the curve equal 8. Equation of tangent is y minus y1 mx minus x1. Y minus 3 equals 8x minus 2. Simplifying it, you will find that the equation is y minus 8x plus 13 equals 0. Equation of the normal to the curve is y minus y1 equals negative 1 over mx minus x1. Y minus 3 equals negative 1 over 8x minus 2. After simplifying it, the equation will take the form 8y plus x minus 26 equals 0. Example number 4. Find the equation of the tangent to the curve y equal 4x minus 10x at the point pi over 4 and f of pi over 4. dy by dx will be 4 minus 6 squared x. To get the slope of the tangent, you will substitute x by pi over 4, which is equivalent to 45 degrees in degree measure. So the slope of the tangent in this case will be equal to. Now I have the value of x is pi over 4. To get the corresponding value of y coordinate, substitute in the equation by x equal pi over 4. So y equal 4 times pi over 4 minus tan 45, because this angle I converted it from radian measure to degree measure. So y will be pi minus 1. So the point pi over 4 and pi minus 1 lies on the curve. Equation of the tangent to the curve is y minus y1 mx minus x1. Y minus between brackets pi minus 1 equals 2 x minus pi over 4. After simplifying this equation, you will find that the equation will take the form y equal to x plus pi over 2 plus 1. Example number 5. If the curve y equal ax bar 3 plus bx squared touch the straight line y equal 8x plus 5 at the point negative 1, negative 3. Find the two values of a and b. So this point negative 1, negative 3 satisfies the equation of the curve. I will substitute it in the equation of the curve. So negative 3 equals a times negative 1 part 3 plus b negative 1 squared. After simplifying it, the equation is a minus b equal 3. This is number 1. The first derivative of this function equals also the slope of the tangent, which is mean the slope of the straight line y equal 8x plus 5. So dy by dx from here equals 8. So now the slope of the tangent to the curve at the indicated point negative 1, negative 3 equal 8. From the equation of the curve, the first derivative will be 3ax squared plus 2bx. This will be equal 8 when you have substituted x by negative 1. 3a times negative 1 squared plus 2b times negative 1 equal 8. So 3a minus 2b equal 8. This is equation number 2. By solving the two equations 1 and 2 simultaneously using calculator mode 5.1 or substituting method or omniting method, you will find that a equals 2 and b equal negative 1. The last example, number 6. If the tangent to the curve y equal 4 over x at the point C at the first quadrant intersects the two coordinate x at the 2 points M and N, prove that area of triangle MON is constant and doesn't depend on the position of the point C lying on the curve of the function, where O is the origin point. So you have y equal 4 over x. I can write it as 4x bar negative 1. Point C consists of two coordinates. I suppose that x equal a. By substituting in equation of the curve, you will find that y equal 4 over a. Let's draw this function. This rational fractional function we talked before in the first term. The blue curve represents the part of the rational function 4 over x in the first quadrant, and the straight line mn is the tangent to it. dy by dx is negative 4 over x squared. Now slope of this tangent at the point C will be negative 4 over a squared. Forming the equation of the straight line mn, which is the tangent to this curve, y minus 4 over a equal negative 4 over a squared x minus a. After simplifying this equation, you will find that the equation of the straight line mn is a squared y plus 4x equal 8a. Now I want to get the value of the point M and the point N. Point M belongs to x-axis, so any point belong to x-axis, its y coordinate equals 0. After putting y equals 0 in the equation of the straight line Mn, you will find that x equals 2a. So the distance from the origin point O to M, which is OM, equals 2a units. Similar way to get the value of N belong to y-axis, so you will put x equals 0. So y in this case equals 8 over a. So the distance from origin point O to N, which is ON, equals 8 over a units. Area of triangle MON, which O is the origin point, is half times base times corresponding height. Half times OM times ON. Half times 2a times 8 over a equals 8 square units. So the area of this triangle MON is constant number and doesn't depend on the position of the point C which lies on the curve. Thank you.